types of strokes that you can categorize into two different categories. You can place in two different categories. One is an ischemic stroke, and one is a hemorrhagic stroke.
Yeah, give me one.
The two types of ischemic strokes, thrombotic and embolic. Thrombotic stroke is just atherosclerotic plaque that builds up in a vessel and just closes it off. Embolic means that there's a chunk of plaque or clot from some other place, namely most often the heart. It gets embolized to the brain. The thrombotic strokes usually occur in bigger vessels. The embolic strokes usually involve smaller vessels. Hemorrhagic strokes, two different breeds there. Intracerebral means deep brain. They're inside the cerebral cortex. They're tiny, tiny vessels, and those vessels are called striate vessels, and they usually rupture because of out-of-control hypertension. Versus extracerebral hemorrhagic strokes that are bleeds like aneurysms and AVMs. I'll talk about each of those here in a minute. When I was in school, our treatment for hypertension wasn't, it was just kind of coming into vogue. 75% of strokes were hemorrhagic. So now, because you treat hypertension so aggressively, it represents a small number of strokes. Most strokes are going to be thrombotic or embolic. Risk factors for stroke, I guess for all four different types of stroke, some more than the others are listed here. Treatment for HIV because it involves jacking with the liver and fatty metabolism and lipids. So they have a hyperlipidemic state, which is also a risk factor. Bruits in the carotid circulation especially. Transient ischemic attacks. TIAs are, you might hear them referred to as mini strokes. You're going to have a lecture on stroke next week anyway. The difference between a TIA and a stroke is that the focal neurologic signs that are present in a TIA resolve within 24 hours. If they don't, it's a stroke. Protein C or S deficiency or the presence of factor V Leiden produce hypercoagulable states. Oral contraceptive pills, not so much so anymore because the amount of hormone has gone down since they were originally invented. Smoking is a lower risk factor. You still wouldn't put a 35-year-old woman who smokes on oral contraceptive pills. That's sort of the cutoff right there, 35, because of age. Now, some considerations in stroke. And by the way, the bottom thing lists the Cincinnati pre-hospital stroke score or scale, and it's based on the three things that I mentioned yesterday: facial drooping, slurred speech, and pronator drift. The incidence or the likelihood of stroke is pretty high, even with one of those. And if you have two of the three, it's greater than 85% you have a stroke. You're having a stroke. Now, some things to consider here. Start with the ischemic down there, ischemic stroke. So the ischemic stroke is going to be thrombotic or embolic, right? You're not putting anything into the cerebral vault. You're not bleeding into the cerebral vault, so you don't have a headache. But because you're blocking part of the nervous system, you will always have focal neurologic signs. So if somebody comes in, something ain't working, no headache, first thing you should think of is an ischemic type of stroke. Loss of consciousness is usually not going to happen with an ischemic stroke. An intracerebral bleed, they also usually don't have a headache because you're dealing with tiny arteries in very important areas of the nervous system, deep brain structures, They will have focal neurologic signs, but they usually don't have a headache. If the bleed is large enough, they lose consciousness because of the deep brain centers that it's around. Now, the extracerebral bleed there is you're increasing a lot of volume into the cerebral vault, so the presenting symptom is headache, not focal neurologic sign. And that's kind of the way to look at things. With an extracerebral bleed, you don't have unconsciousness until it gets way out of hand. So a person comes in with a headache. Allison comes in with a headache. What's the differential for a headache? We're going to talk about headache tomorrow. I'm actually going to do a headache lecture tomorrow instead of CNS infections. But if she comes in with a headache, it could be a headache, it could be a migraine, it could be a cluster, it could be a tension, it could be a menstrual migraine, you know, whatever. It could also be an extracerebral bleed. Do I let her go home, or do I investigate her for this? Two things that should alarm you. One is, if she says, it's the worst headache I've ever had in my life, or if she has focal neurologic signs, automatically you get a CT of the head. Infarction, here we go with a thrombosis. You see that area there representing the distribution of what artery is that? Middle cerebral, that's the middle cerebral. Yeah. And branches of the middle cerebral. Okay? There's the explanation for TIA. Some people have TIAs that will get launched down in the ophthalmic artery, the retinal artery, and they'll go blind in one eye temporarily. That's called amaurosis fugax or fugax. Temporary blindness in one eye is amaurosis fugax. It is due to a TIA. Risk factor for stroke is TIA. That's why it says you need to treat these people aggressively. They need to be anticoagulated. You need to get after them to prevent the big stroke. The emboli, as it says here, are going to be mostly the small vessels, and depends a lot on where it is, where it's going, what's blocked. These things are what you're going after with the clot busters, recombinant TPA. Recombinant TPA. If you go back to back in Intro to Human Form, you know, I gave a lecture, we talked a little bit about blood clotting, and I mentioned that TPA is synthesized and released by the endothelial cells, and that's what you're giving them. You're trying to break down this clot. Ideally, you like to get it on board, TPA on board, intravenously within 3 hours after the onset of symptoms, but that can be played with a little bit more. The longer you wait, the less likely it's going to make improvements, and the more likely the risk of creating an intracerebral bleed from using TPA outweighs the benefits you get from saving some of your nervous system. That make sense? Here's a hemorrhagic stroke here. This is not a good thing. Note that hemorrhagic strokes are not confined to arterial distribution. If you block an artery, then you're going to affect downstream stuff. Bleeds are going to percolate around all over the place and affect things more globally. Because these things can be so massive, as it says in that first slide there, death is more likely to occur in the first hour following the bleed. This is why you get a CAT scan with somebody coming in with a stroke. Ron comes in with stroke symptoms. I get a non-contrast CAT scan. I don't want to give him a contrast CAT scan because I don't want contrast there. Non-contrast CAT scan to demonstrate that he is not having an hemorrhagic stroke. Then he gets TPA. Berry aneurysms are really common, 1 in 20. That means about 2 people in here have a berry aneurysm and don't know it. They usually occur in the circle of Willis, mostly along the middle cerebral artery where its branches. Over half of them are there. You know, if you live your whole life with berry aneurysm, no big deal. If they rupture, they can cause sudden death because of the pressure in that system. If you identify one of these things by some means or another, there are different ways to fix them. One of the ways, the extravascular way to fix it, is to go in there and put an aneurysm clip on the stalk of the it looks like a little pituitary, right? It's got a stalk. Most of them do anyway. You just clip it, aneurysm clip. The other way to do it is to go in through the vessels here, get up in there with your camera, with your instruments, and you thread this wire into the aneurysm. It's called coiling. And Georgiana Snowden at Baptist is the one that's the expert in the state about coiling aneurysms. And what the purpose of this coil is that it produces the nidus for a clot. And what happens is a clot forms in the aneurysm and it's no longer a problem, no longer a threat. Yes, ma'am?
Is there ever a concern for an embolus from the clot?
No, no. Now, these things work best there. You can't have a long stalk there. You got to be able to get inside the thing to thread that little thread in there. They also typically will put a stent in there to keep it open, keep the vessel open.
Do you leave that coiling in there?
Yeah, it stays in there. Stays in there. Yeah, you clot around it. Yeah. Anything else? Okay. Vascular malformations, there are 2 types that are present. Again, it's a really large number of the population. One of them is a venous malformation. This is the most common type. And basically, this is a cluster of varicose veins. That's all it is. The other type that's more threatening, though, is an AVM, an arteriovenous malformation. That's where you have an artery attached directly to the vein without going through the capillary bed to lower the pressure. So you have the big, greasy, dilated veins. It's much worse than just varicose veins of the brain. These things rupture and it's lights out. Okay? You usually don't have a lot of time to deal with them. These things are mostly on the surface of the brain, so this is where you're going to find a positive hemorrhagic tap back here. Meningitis, I'm going to talk a lot more about meningitis later on, but I just want to introduce it here. 2 basic types of meningitis. The bad type is the bacterial meningitis. This is a medical emergency. The other type is called aseptic meningitis. In aseptic meningitis, they call it aseptic just because bacteria don't grow out. Aseptic meningitis most of the time is due to a virus, one of a bunch of different types of viruses, but it can also be due to things like tuberculosis, herpes, other types of things like that. So it can be serious, but aseptic meningitis or viral meningitis is, you can send a patient home with that. Bacterial meningitis, they have to be hospitalized and on IV antibiotics. The problem is you can't tell them apart initially when they present to the emergency room or to your clinic. So you have to work them up and know what you're dealing with before you make a decision on do they go in the hospital or do they go home. Here's something that you should keep in the back of your mind here, that if you have a focal neurologic sign and you're thinking meningitis, you might want to think again. You typically don't have focal neurologic signs when you're dealing with meningitis. A couple of concepts here. I'm going to go into these more later on. The first one is delirium. Delirium is a transient state. It's a correctable state. It can be caused by one of a number of factors. There's some of them right here. Vitamin deficiency, like the alcoholic. So one of the treatments here, when you're dealing with somebody in delirium, now delirium presents, these people are confused, they don't know where they are, they are not alert and oriented to person, place, and time. Is a thing called a banana bag. The reason it's called a banana bag is an IV bag that has a yellowish tint to it. Some people refer to them as a rally pack. Basically, it's just a bunch of vitamins, including thiamine and magnesium, because alcoholics are almost uniformly magnesium deficient. That's a lot of magnesium sulfate right there, but you give it over a few hours, so it perks them up and you send them on their way. Here's another example of where you give thiamine before you give a bunch of glucose. Okay? Versus dementia is not a correctable state. Ain't no rally pack going to work on dementia. Dementia is a progressive, slowly progressive disorder. They present the same way, confused, don't know, come here from sickum, that sort of thing. But it's due to some, most of the time, some organic problem like Alzheimer's disease. And we'll spend a lot of time on Alzheimer's later on. Alzheimer's dyscalculia, you just can't do numbers. They can't do numbers. Is an early sign of dementia. Alzheimer's specifically has these three types of issues when it comes to the nervous system: plaques, tangles, and amyloid. Plaques, tangles, and amyloid are present in the brains, the autopsy brains of Alzheimer's patients. Multi-infarct dementia is a condition where a person keeps throwing a bunch of small infarcts over time, and they're not big enough to say, oh, they're having a stroke, but they do over time destroy the cortex and lead to a progressive dementia similar to what you see in Alzheimer's. This is a video I shot the other day in Walmart. This is a guy with Tourette's syndrome. It's either Tourette's syndrome or jacked up on meth. But I shot this video and I just wanted to share this real quick. This is a movement disorder. We're going to have a lecture on movement disorders next week, but oh, it's sideways.
Oh my God.
You see that guy right there? Watch him here. I mean, that guy cannot be still.
Her legs set up the orange juice.
That was about as far as from me from Ronnie to him. I mean, so, you know, that's another type of movement disorder, Tourette's syndrome. So Tourette's syndrome, you know, is an outburst of a lot of profanity, often profanity in people, but it also manifests itself as just tics. You know, they just can't stop moving like this guy. I mean, he was all over the place. And I didn't even get the good video. You should have seen it when he was at the strawberries. Huntington's chorea is, as it says here, autosomal dominant disorder. It's a lot. So when you're talking about movement, you know, I talked about basal ganglia yesterday. Basal ganglia. You've got a couple of areas here. And I'll go over this more when we do deep brain structures here. There's a circuitry here that goes between the caudate nucleus and the substantia nigra. The caudate nucleus is that one right there. The putamen is also part of it. In Huntington's chorea, you have a loss of GABAergic neurons that input to the substantia nigra. In Parkinson's disease, you have a loss of dopamine neurons to the called equina. They're related, almost. Huntington's chorea is fascinating in that it's actually due to a mutation that produces an elongation of the CAG repeats in the Huntington gene. And as you have a subsequent generation, this repeat gets longer and longer. And as it gets longer and longer, the people downstream that inherit it inherit an earlier and earlier form of the disease. So they, instead of coming on in the 40s and 50s, now it's coming on in the 20s and 30s. So it's a pretty disastrous disease. It's uniformly fatal over time. It starts out as motor, where they can't control. Chorea form movements is a movement like this, and they can't control it. And you start having these types of spasms in the larynx, and you're going to wind up aspirating saliva and die of respiratory disease later on. Usually for the longest period of time, they are fully cognizant of what's going on. It's not till later on that dementia set in, but by then they're wheelchair bound. They're not, it's a horrible disease. And usually it occurs after you've already had children, so you've already passed the gene on in your family. Parkinson's disease is, like I've said here, we talked about all of these things up here, but also you need to realize that about half of Parkinson's patients will develop dementia as they get older. Back in the, I believe it was the 70s, these cats out in California were trying to make some synthetic opioid, and when they did, they were trying to make some stuff called MPPP. When they did, they screwed it up and made some stuff called MPTP, which selectively poisons the substantia nigra. So you were having these 20-year-olds coming in with full-blown Parkinson's disease because they had gorked their own substantia nigra with this synthetic heroin. So not synthetic heroin, just synthetic opioid. Don't take any opioids that were made in a garage, okay? That's the ALS is a degenerative disease. There are two forms. One is familial, the other is sporadic. Most of it is sporadic. Only about 10% is familial. Most of it is sporadic. It involves a demyelinating disorder that involves the demyelination of the descending tracts, corticospinal, and the ventral horn cells of the spinal cord. It's a bad disease. There's some treatment for it, but it's really not going to extend your life that considerable. Okay, usually with 3 to 5 years. The most common demyelinating disease, though, is multiple sclerosis. Multiple sclerosis is mostly in young adults. It says 20 to 40 years, mostly young women. A young woman, 30 years old, presenting to with pain in the eye, blurred vision, and on MRI she has optic neuritis, has multiple sclerosis until you prove otherwise. The telltale sign of multiple sclerosis are plaques in the central nervous system, in the brain, that you can see on CT. That's the diagnostic feature right there. Multiple sclerosis comes in a bunch of different forms, relapsing, progressive, and all that sort of thing. Some people can have an episode of weakness, these different symptoms, and then they never have another one for 10 years. And then it comes on and is much more progressive. The usual course is a slow, steady decline. You're going to wind up in a wheelchair eventually, and unfortunately, they usually don't have a normal lifespan. They'll usually live, maybe 20, 30 years, but they usually succumb because of things like respiratory failure or infection. Guillain-Barré, I mentioned yesterday, The thing I think I failed to mention yesterday, I said it returns, your nervous system returns its function from a proximal to distal direction. I need to tell you that happens usually within days to weeks. In only a small percentage of people is it a permanent issue. Usually though, they have a full recovery. Metabolic diseases, Tay-Sachs and Niemann-Pick are a couple of them that I've listed here. These have to do with gangliosides or the construction of the axonal membrane, or the neural cell membrane. These people with these types of inherited inborn errors of metabolism, that's what they are, usually die in early childhood. Tay-Sachs is when you say Ashkenazi Jew, you say Tay-Sachs. So people are screened for Tay-Sachs disease, the gene defect. These kids usually die within 3 to 5 years old. People with Niemann-Pick, they live a little longer, but usually in teenage years they'll die. They're uniformly slow development, and they're not able to live outside on their home. I mean, you wouldn't have a 3-year-old living on their own anyway, but it's development is delayed significantly. Here is when you're talking about inborn errors of metabolism, they come in really 3 different groups. One of them is lysosomal storage disease. One of them has to do more with proteins and porphyrias, or the breakdown of hemoglobin through porphyrins. The other one here is the glycogen storage disease. So lysosomal versus glycogen storage disease. The symptomatology, it's everything. It's everything. It can be everything. But they're uniformly delayed development, delayed mentally, and usually will die at an early age, not have a normal lifespan. Here's the graph that I love that. If you want to know the inborn error of metabolism, pick any point in your biochemistry and take that enzyme, there's a defect for it. So that's what, I love this slide. The test, I'm just going to make this the test. Neoplastic disease. One thing about neoplastic disease is there's not a specific telltale thing about neoplastic disease. You know, a strawberry cervix, if you got a strawberry cervix, you got tricked. There's no marker like that for neoplastic disease in the head. What the presenting complaint is going to be something like headache or focal neurologic signs or blurred vision, something like that related to the growing mass. Okay? It says all CNS neoplasia is potentially biologically malignant. The thing is, CNS neoplasms rarely lead to CNS. You're going to die before they do. Okay? It says the overall incidence of CNS neoplasia increases with age. However, if you're looking at the relative ratio or the percentage of CNS disease in children, it's the second most common type of cancer that they get behind the hematologic cancers. Astrocytoma is the one that's the most common here. Well-differentiated astrocytoma. These things can develop anywhere within the central nervous system. And they are truly tumors of astrocytes. This would be like a grade 1, 2, or 3 here. There's a good survival of grade 1, 2, or 3. Grade 4 is also called glioblastoma multiforme. It usually occurs in people around my age. And it says here, if you don't treat it, you're going to live maybe 3 months. If you do treat it, you might make it out 1 year, but not likely. Dr. Vanetta's daughter-in-law died of this just last year, and I think she lived maybe a year, so with aggressive treatment. So, unfortunately, it was inoperable. Her tumor was right there, so they couldn't get at it. I think they actually did try to debulk it, but they couldn't get it all because it like cancer, it grows into tissues, and you can't pull it all out. Metastatic tumors to the brain, though, are quite common in this order here. Lung, breast, melanoma, that's the ones that we are particularly worried about. Lung, breast, melanoma. Where does it metastasize? To the brain. The thing about metastasis to the brain versus an astrocytoma, an astrocytoma can develop anywhere in mostly the white matter. Okay, it can be gray matter, a lot of times white matter. The thing about metastatic disease, like lung cancer going to the brain, it usually shows up at the white-gray matter junction. So if you see something, a mass in the white-gray matter junction, then you need to be thinking about, oh, that may be metastasis from somewhere else, not a primary tumor of the CNS. Okay? Muscle diseases, the only reason I did the muscle diseases here is because we're talking about nervous system, and you can't really talk about nervous system without talking about muscle. The two that we want to talk about here are muscular dystrophies. And the primary muscular dystrophy we're going to talk about here is Duchenne-type muscular dystrophy. This is a sex-linked recessive disease. It mostly affects boys. What happens here is it's a protein deficiency due to a gene mutation. It's profound muscle weakness, and mostly the trunk muscles. So the classic picture of a kid with Duchenne muscular dystrophy is that they're sitting on the ground and you want them to stand up. They can't just stand up like this. What they have to do is they have to more roll over and work their way into a standing position. They usually do not live a normal life expectancy. So pelvic girdle muscle, that's what I was trying to say. I said trunk, but pelvic girdle, same thing. Okay. The other thing is myasthenia gravis. Myasthenia gravis is an autoimmune disease where you develop autoantibodies against the acetylcholine receptor on muscles. So the alpha motor neurons have their motor end plate, right? The alpha motor neurons from the ventral horn, motor end plate. The neurotransmitter is acetylcholine. Those receptors, those postsynaptic receptors, are blocked in myasthenia gravis. And they mostly affect muscles with high utilization. Your extraocular eye movement muscles, mostly they see it, they come in and say, I can't keep my eyes open. It's your eyelid, your upper eyelid muscle, your levator palpebrae superioris, that it tires first because of myasthenia. The treatment for it is you give them an acetylcholinesterase, which is the enzyme that breaks down acetylcholine, inhibitor. You inhibit acetylcholinesterase, thereby having more acetylcholine available in the junction, and that's the treatment for it. If you don't take that drug at the precise time that you're supposed to take it, usually it's, I think, twice a day, you have to take it before you go to bed. You will die during the night when your diaphragm stops working. So, okay. Prion disease, I don't know if you know much about this. Anybody know, you guys know what these things are? Some of you? This is the coolest stuff in the world. You need to spend time on the last few slides here. This is a protein that you make. You have a gene for the PRP. It produces a protein. This protein, if there's a mutation, it can. So a protein has a primary structure, which is just an amino acid sequence. The secondary structure is its sort of initial folding. The tertiary structure is its three-dimensional folding. This is a misfolded protein. Okay? It's a misfolded protein. When this misfolded protein comes in contact with other proteins in the central nervous system, it causes them to misfold. So it induces misfolding in normal proteins. It doesn't replicate itself. it just causes others to misfold. And when it misfolds, and when these proteins misfold, the neurons die, and when the neurons start dying, they produce holes in the brain. These are called collectively spongiform encephalopathies because it looks like a sponge. I'll show you a slide of it here in just a minute. The thing about this is that the concept of the self-replicating protein is wrong. So the thing about this is, the question is, can something that does not contain nucleic acids replicate? It defies convention. By defying convention, we're talking about the central dogma of molecular biology says that in order to get a protein, you have to have DNA that codes an RNA that codes protein. You have to have transcription and translation. That's the central dogma. That's what everybody believed for decades. Until these things came along, where suddenly you've got a protein inducing something in other proteins. And also the central dogma went away when the retroviruses came on board and reverse RNA, reverse transcriptase was discovered. Anyway, these things, the spongiform encephalopathy in sheep is called scrappy. You get these sheep that act just nuts, right? They're uncoordinated, they're goofy, they just don't behave like sheep. In humans, it's called CJD, or Creutzfeldt-Jakob disease. It's on another slide. Creutzfeldt-Jakob disease. The discovery of this protein led to the Nobel Prize. That's how important it was. So here's a little bit about the prion. It's conserved, it's in a lot of mammals. The protein itself that you normally do. It has some role in copper metabolism, they think. Not sure exactly what, but it's present in just about everything. So here's the thing, is if you have this misfolded protein and I eat your brain, then now I've ingested the protein and it will start to work on me. So one of the things about this is that prion disease is infectious. Okay? These, it says here they're classified generally as transmissible because you can, it's infectious. All right? Misfolded protein, that's all it is. Death usually occurs pretty soon. This is what it looks like. You see all these punched out holes in the CNS of something here, a cow. Bovine spongiform encephalopathy is mad cow disease. It looks just like CJD. Okay, so on the infectious side, if you eat tissue, infected tissue, you're going to get it. You're going to get CJD. If you happen to be a cannibal living in New Guinea in the 19th century, you had these women that were just mad cow goofy. They called it kuru. They were actually ingesting prions from the cannibalized brains from their whoever they were eating. Okay, if you do a YouTube video of kuru, you've got these 1940 videos of these women that are really crazy, and that's what's going on there. Unfortunately, you can't kill this thing because it's not alive, and it stays around forever. That's why all instruments in neurosurgery now are disposable, because it turns out that they were giving people CJD by doing grafts of dura or using instruments from one patient to the next. Even though they'd been autoclaved, they were transmitting CJD from one patient to the next. That's why all instruments in neurosurgery are disposable now. Okay? And you can see, some interesting things up here. The thing about mad cow disease is that the variant disease, there were a group of people, 155 cases of CJD in England or Great Britain as a direct result of mad cow disease. That's why they killed all those cows over there. But these people were having CJD at a very young age versus a normal age where it would show up at an older. Here's the thing that's really awful here. On the hereditary side, you can, there are a group of a certain select number of families in the world, there are not many, 50 families worldwide, that pass this mutated PRP gene in their family. And what this produces is fatal familial insomnia. This is something they develop as an adult, and suddenly they can't go to sleep. And they live, if you cannot go to sleep, you will live for just a matter of weeks before you die. And if you do a YouTube video of fatal familial insomnia, you'll see these people, it's just awful, but it's confined to this, this select group of people in the world. Okay? Like Huntington's disease, it started out with one person, and then that turned into what we see there. That's all I want to talk about today. So, hope you have a good night.